Systems and components 20. Can you use enthalpy values from the outdoor air and return air conditions to find the leaving enthalpy value, or do you always have to subtract the dry bulb temperatures and then divide by the dry bulb minus the wet bulb values? So this question was about an air-to-air heat exchanger. And we're being asked a question about wet bulb, I think, ultimately in the question. And your question is, do you always have to subtract dry bulb temperatures and divide by dry bulb? So if you have an enthalpy wheel, then the efficiency of the enthalpy wheel can be set equal to the proportion of the dry bulb temperatures or the enthalpies or the humidity ratio, any of the three, because it's sensible and latent. So if we have the efficiency, and this is only for an enthalpy wheel now, we can say that, and I'm going to use these numbers, but you should really think about this more in concepts and words. But I'll say T1 minus T3, which is the actual delta T that you're getting through the enthalpy wheel, as compared to T1 minus T2, which is the maximum possible delta T that you could get. Right? That can only ever be 100%. It's probably going to be a lot less. That's equal to the same for the humidity ratio, because the amount of sensible cooling that it does, its efficiency, the efficiency with which the enthalpy wheel does sensible heating or cooling, or sensible heat transfer, I guess you could say, is the same as the efficiency with which it does latent heat transfer. So humidity ratio 1 minus humidity ratio 3, the delta humidity ratio actually, as compared to the delta humidity ratio possibly, maximum possible in the denominator. And then what's the parameter that puts those two ideas together, both sensible and latent? Well, of course, it's the enthalpy. So H1 minus H3, the actual change in enthalpy, divided by H1 minus H2, the maximum possible change in enthalpy. All of those ratios are equal to each other and to the efficiency for an enthalpy wheel. And another word for enthalpy wheel is an energy recovery device. Key word there being energy. Energy inclusive of sensible energy and latent energy. That is not true with an air-to-air heat exchanger, which is a sensible heat recovery device. So this problem was about an air-to-air heat exchanger. So now the only the first one, I'm not even going to rewrite it. Only this holds true for a sensible heat recovery device, such as an air-to-air heat exchanger. So the answer to your question, can you use enthalpy values? The answer is no, not for this question, because it's an air-to-air heat exchanger. So you can only use this. But if it was an enthalpy wheel, then yeah, you could go to this. So the technique, the method used in that solution, if you go back and watch the solution video, there's a very good reason that I do not write either of these expressions. I kind of come at it a different way, and we're able to find our way through and answer the question.